Welcome to the video tutorials of the book Methods, Evaluation and Research in Education by Mohammad Aktaruzzaman. And today we're going to learn how to do ANCOVA in SPSS. In fact, this is an inferential statistical test. Variables that are not part of the main experimental manipulation but have an influence on the dependent variable are known as covariates, and they can be included in the analysis of variance. Inclusion of covariates in ANCOVA is also termed as analysis of covariance, which is known as ANCOVA. Let's go to an example. Suppose three groups of students have been initially tested for their computer literacy and their scores are recorded. Then they have been subjected to different treatments like lecture, CAI and blended method. And after 30 days of such training, they are again evaluated for their computer literacy, and these final scores are also recorded. The data are kept in a file called ANCOVA. There are many observable differences among the initial scores of the three groups, but no attempt was made to make these groups as equivalent groups before subjecting to different treatments. In the absence of such an experimental control, the researcher was forced to exercise statistical control by applying the technique of analysis of covariance. In this particular case, we have to study the impact of the treatments given to the groups on the final score and also check whether the differences in their initial score have any significant impact on the final score. Now, considering the above scenario, we are going to conduct the test ANCOVA at 0.05 level of significance. Let's see the SPSS data editor window at the screen. Now, go to File, then open Data, and then Data File under SPSS Evaluation folder, and open the file ANCOVA in the SPSS data editor. Let's see the variable view of the data. There are three variables, which are method, initial score and final score, where method is of numeric type and the scale of measurement are nominal, and initial score and final score are also of numeric type, but it's of scale data. In the values column, method variable is classified as 1 for lecture method, 2 for CAI method, 3 for blended method. Go back to the data view of the SPSS data editor. You see the variables at the top of each column and also see the initial and final scores of 15 students with respect to different methods of teaching they are taught. The pattern of data view is different from the usual one. You can change the data view pattern by clicking the value labels icon, which is third from the right at the toolbar just below the menu bar. Now go to Analyze menu, then General Linear Model, then Univariate. Take the final score as post-test in the dependent list and method of teaching in the fixed factors field. Click OK. See the table tests of between subjects effects at the screen. The sig value for the method is 0.001 and error is 44.0. For testing the hypothesis, SPSS needs only the sig value to be compared with 0.05. In SPSS interpretation, sig value greater than 0.05 means acceptance of the null hypothesis, and on the other hand, sig value less than 0.05 means rejection of the null hypothesis. As the sig value for method is less than 0.05, which implies the null hypothesis, which is there is no effect of teaching method on the student achievement, is rejected. That means research hypothesis is accepted. So, the teaching method has significant effect on the student achievement. Again, go to the Analyze menu, then General Linear Model, then Univariate. Take the final score as post-test in the dependent list method of teaching in the fixed factors field, and initial score as pretest in the covariates field. Click the Options button and take Method into the Display Means for field. Now select Descriptive and Homogeneity of Variance Test and specify the significance level 0.05, which is already there as default value. Click Continue and then press OK. See the output at the screen. The mean and standard deviation of the final scores for lecture, CAI and blended method are shown in the table. Descriptive statistics. In the table Levin's test of equality, the sig value is 0.217, which is in fact the sig value for homogeneity of variance test. Sig value 0.217 is greater than 0.05, which implies the null hypothesis there is no difference between the variance of the groups is not rejected. It implies that the variances are approximately equal. Let's see the most important table, which is tests of between subjects effect. In this table, there are different sig values, which we are interested only in two sig values, which are 0.004 for initial score and 0.721 for method. See the error in this case is 20.3. In case of covariate, as the sig value for initial score 0.004 is less than 0.05, which implies the null hypothesis is thus rejected. That means research hypothesis is accepted. So, the differences in initial score have significant effect on the experimental manipulation, which is impact of treatments on the final score. At the same time, the sig value for method 0.721 is greater than 0.05, which means the null hypothesis is not rejected. So, there is no effect of teaching method on the achievement of the students. Initially, teaching method has an effect on student achievement, but when the covariate is considered, it is observed that not the teaching method but the differences in initial scores of the student have significant effect on the student achievement, which is the final score. So, initial difference is causing the mean difference. If it is not identified using the analysis of covariance, it can be misattributed that teaching method has significant impact on the achievement of the students. Let's see the error in the table, tests of between subjects effects at the output viewer. The large amount of variation in final score that is accounted for by the covariate has meant that the unexplained variance has been reduced from 44.0 to 20.3. Have a look at it. The total variance has not changed. All that has been changed is how the total variation is explained. One way to discover the effect of covariate is simply to draw a scatter plot of covariate against the outcome, that is, initial score versus final score. Now, go to the Graphs menu, then Chart Builder, and then choose the first type of scatter plot from the gallery. Just choose it. Yeah, drag it there. Drag the variable final score as post-test in the x-axis and initial score as pre-test in the y-axis. To write the titles or footnotes, click on it at the left side and select Title 1 or Foot 1 as per need, and then write in the content box at the newly generated window at the right side. Then apply and then click OK. The resulting scatter plot shows that if initial score increases, then the final score also increases. So, the effect of covariate, which is initial score, is obvious on the final score and it cannot be ignored. Hope you have learned a little bit about how to conduct ANCOVA in SPSS. You may practice yourself on different data set to gain better understanding. Thank you for staying with us. It's Yazdani saying you goodbye.